Hey everybody, this is Mrs. Ellsworth. What we're going to be talking about today is balancing chemical equations. So just looking at this chemical equation, there's this formula right here for methane plus oxygen, and then we're going to get carbon dioxide and water out of it. So what we want to do is we want to go and look at these front ones. In fact, these front ones are called reactants. Okay, that's what the ones all in front of the arrow is. They're all called reactants. And then the ones after the arrow here, these ones are all called the products. So what happens is that I go and I take methane gas and I light it on fire with oxygen and it burns. And once it burns, here we go. This is kind of stopping it. Here's the before the reaction. Here's after the reaction. All we get out of it is carbon dioxide gas and water. So the reactants are the things that we're adding together. And then when we get it at the very end, after it goes through the reaction, all we've got is the carbon dioxide and the water. So there's this one little thing right here, and this is called the yield sign. Okay, and that's going to show what you're going to get after the reaction occurs. So it's kind of like right here is a dotted line before the reaction and after the reaction. Okay, so I'm going to erase those, and then we're going to talk about balancing chemical reactions. Oh wait, let me talk about two other types of terms that you need to know. So when we were doing this before, we would create our formulas by using subscripts. And we've had that word also in our notes. But now what we're going to do is we're going to go and add coefficients in front, so we got the same number of carbons over here as we do over here. Same number of oxygens over here as we do over here. So I've got a couple of things that make this a whole lot easier. First thing, always leave oxygens till very, 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 very last. You'll find that sometimes you can get some headaches with them. Okay, the next thing is leave hydrogens second to last. That doesn't always work perfect, but it works pretty well for me, and it helps me be a little more successful at this. So what we're going to do is we're going to look at both sides. So there's only, this one's the only one with carbon, so one carbon right here, because it's got a one understood right there, right? One carbon and one carbon. So that looks good. We want there to be the same amount on both sides. Now look at the hydrogens. I've got 4 hydrogens here, and I need to make 4 here. I can't change my subscript. That will change what water is. So I've got to change a multiplier in front of it. This multiplier has a special name. It is called a coefficient. Okay, and it is a multiplier for everything behind it. So like if I was going to put a 2 in front of this one, it would go all the way to the next plus sign. Okay, so it would double up the number of carbons, double up the number of oxygens if I did that. But that doesn't work for this one. So just looking at the hydrogens again, let's get back there because I kind of sidetracked with some terms. We've got 1 carbon, 1 carbon. We've got 4 H's. Now I've got 2 times 2 is 4 H's here. Now I've got 2 oxygens, look at this, plus 2 more oxygens. So 2 plus the 2 here, because this 1 is a multiplier, this 2 is a multiplier of that 1 there. So we've got 4 oxygens total over here. No oxygens there, here they are here. So I've got to put a multiplier in front of it. And so it goes just to the oxygens to the next sign. So it's going to be 2 times 2 is 4 oxygens. We had 4 oxygens over here. This thing is balanced, and that's what our goal is of each one of these. First of all, to write out the chemical formulas perfectly using subscripts and doing the ionic ones where you switch them, and then the prefixes with the covalent ones. Okay, and then after we got all the formulas written perfectly, then we will go and put coefficients in front of them for when we have to multiply them. Now in chemistry, you know we don't write ones, but there is really ones right here too. There's one of this molecule, one of this molecule also. And we don't write them. If you need to write them to help you understand it better, that's fine. Okay, that's fine. So let's look at the next one. Okay, we've already got the formulas all written out for us. That's so nice. So we've got 1 sodium, 1 sodium. 1 I, 2 I's here. So what can I do? I can't put a 2 here. No. This formula is sodium iodide. It's got a +1 and a -1. They did the switcheroo already. Okay, so they got 2 I's, so I need to put a coefficient in front of this one and make 2 I's here. Okay, that screwed up the sodium. So here we go. We got 2 sodiums We're going to make 2 sodiums here. Look, there's 2 sodiums and 2 iodines on each side of the yield sign, and that makes that one balanced. So that one's lovely, just like it is. Okay, notice I got 1 sulfur, 1 sulfur. Now I got 3 and 2. What? So you got to find a common multiple. So we know that 3 and 2, a common multiple of that is going to be 6. So we're going to put a 2 in front of this one and a 3 in front of this one. So 3 times 2 is 6. 2 times 3 is 6 also. And then that changed the sulfurs, so we got to go back and fix the other sulfurs. There's 2 sulfurs here. We'll make 2 sulfurs here. Okay, so those ones are pretty nice when they've got the formulas all written out for you. But down here we don't have that. So we've got to figure out the formulas for each one. Now, there are, okay, so let's go and look at this. So sodium, notice it's in a compound. It's got 2 words here. It's got one element and another element is in a compound, so we've got to figure out what it is. It is ionic because it starts with a metal. So sodium is Na, and it's got a +1. Bromine is a -1. And if you need to stop and pause and check with this with your periodic table or your polyatomic ion chart, do that. So we're going to do the switcheroo, and so from this one we're going to get NaBr. Okay, then the plus sign just comes on down. So it's going to be kind of written like these were. Okay, chlorine. Chlorine is alone. And you don't worry about anything with chlorine except for if it's special. And on your purple polyatomic ion chart, right in the bottom center it says diatomic molecules. And you always have to look when they are alone to see if it is a diatomic molecule. So go check that out. But anyways, chlorine when it is alone is special. It is diatomic. So it is so reactive that it will never be alone. So you always got to put that little baby 2 right there. So Cl and a little baby 2 right there. Remember how oxygen had that? Iodine had that? Those are other ones that are special. They are diatomics, and they're special. Okay, they are too reactive to be alone. Okay, and then we got our arrow here, and then sodium again is a +1. Chloride is a -1. So this is the same stuff we've been doing, but now we're putting it all into one of these sentences here. So this is, we're doing our switcheroo, and we get NaCl. Okay, now notice that this chlorine here did not have the 2 because, again, diatomics are for only when they are alone and when they're a single atom, or a single element, I should say, and they're alone. Okay, so this would never have a 2 unless this had a 2 here and you did the switcheroo. So that's the only way that that would happen. Okay, so then bring this plus down here, and then bromine. Bromine is alone. It's just one single element. So we still got to go look and see if it's special with those diatomics. And it is. So you got to put that little baby 2 there. So these are subscripts. Br2. Okay. So now we've got every formula written out. So now we need to balance it. So let's go ahead and do that. We got 1 sodium, 1 sodium, 1 chlorine, 2 chlorines. So I need to put a multiplier for here. I can't put it here. I can't put it here. It must go in front of it. Even though it changes the sodiums, who cares? We'll go back and fix the other ones. So we've got 2 sodiums and we've got 2 chlorines. 2 chlorines. Let's put in the 2 right there. Okay, now we've got 2 sodiums. Now we've got 2 bromines. And we've got 2 bromines here. That's the lovely thing about when you balance a chemical equation. When it works out like that, when you get to your last element, those 2 bromines and 2 bromines, it just, you know that it's correct because it balanced out so lovely. Okay, let's look at the next problem. Okay, we got barium, and it is a +2, and hydroxide is a -1. And so we're going to go do our switcheroo with that one, and we get BaOH and a 2. See, if you didn't get the right formula and you didn't put those parentheses there, it could be wrong. Okay, and then plus, and we've got hydrogen monochloride. So this is the diatomic one, and so hydrogen is alone, and mono means 1, chlorine, 1, and so HCl, okay, HCl. Okay, and we got barium coming up next with chloride, but let's write in that yield sign. Okay, barium is a +2 again, and then chloride is a -1, and so we do our switcheroo. We're going to get BaCl2, and then we get water, H2O. We like that one. Okay, here we go. We got 1 Ba, 1 Ba. 2 Cl's, I need to make 2 Cl's here. Now, we would want to think, well, 2 hydrogens, and then look over here, but look at all of them. You've got 2 hydrogens plus 2 more hydrogens, because there's a plus sign between them. So 2 hydrogens plus 2 hydrogens, 4 hydrogens on this side. I'll just write that down to remind myself. I need to make 4 hydrogens over here. It's the only one with hydrogen, so I'm going to put a 2 in front of it because it's a multiplier. So that's 2 times 2 is 4 hydrogens over here. So that's nice. I've also got 2 O's, and I've got 2 O's right here. So this one's balanced just like this. This has got lots of points in it because each formula is correct, and each correct coefficient in front is also another point too, so it's got quite a few. Okay, here's another one. We've got iron. It's alone, so it's just Fe. We just got to check to see if it's special. And it is not special. It's not on that diatomic molecule on your purple polyatomic ion chart. Okay, so it is just Fe. Okay, bring down that plus sign. And sulfur, it is alone. Check to see if it's special. Is it? No, it's not. So it's just an S. Okay. We'll bring down our yield sign. And then we got iron 2, Fe plus 2. And then sulfite is a negative 2. Well, isn't this nifty? So those two will be a 2 to 2 or a 1 to 1 ratio. So it's just FeS. And look, it's already balanced. 1 Fe, 1 Fe, 1 S, 1 S. That's, lots of them are like that. That works pretty nifty. Okay? Okay, next one, zinc. Okay, zinc is alone. And look on that purple polyatomic ion chart in the bottom, in the middle. It is not special. It is not diatomic, so it does not need a little baby 2 there. In fact, you can't put one there or else it'll get wrong. Okay, hydrogen monochloride, so H is sorry, this starts out with a hydrogen which has no mono in the front like it should, so it's just 1H. The monochloride is 1Cl, so it's HCl again. Okay, and then yields. And then zinc, I'm going to write this up, my thinking up here. Zinc is a plus 2. Notice it's in a whole compound. It's a plus 2. And chloride is a negative 1. So you do your switcheroo, and you get ZnCl2. Hydrogen is H, and you just got to see it's alone because there's just one kind of element here. It's alone. See if it's special. Look on that diatomic chart in the middle of the bottom of your purple polyatomic ion chart, and you'll see it is. Okay, now see this word here? We got to show you something more with that. So here's an H2. It's got this little baby G right here for gas. It's really small, just like the 2 is. It's hanging down there. Anyway, so that right there is how we show that. And that will not be balanced with anything else. It's just telling you, hey, when you have this reaction, you're going to get some bubbles. It's going to be hydrogen gas. Okay, so let's go ahead and balance this. We've got 1 Zn, 1 Zn. 2 Cl's. We need to make 2 Cl's here. Again, you cannot put it in the middle of it. It must go in front of it. And it doesn't go here either. Okay? Okay, so we got 2 H's and 2 H's. So this one is totally balanced just like it is right there. Okay. Okay, well that's all I got for you, so I will see you when I see you. Bye-bye.